Hi everyone, it's Dr. Turner for Fundamental Mathematics. Today we're going to be covering 8.2. 8.2 is looking at just basic probability. We'll talk about the formula for basic probability and then look at a couple examples of what that is. So we'll go ahead and just jump right into it. When we look at probability, and you'll see this written different slightly and depending on what book you're looking at, but the probability of an event is given as the number of desired outcomes over the total number of outcomes. And you'll see this written out in symbols and again written a little differently. But basically, if you're writing probability as a fraction, you're going to take what you're looking for over how many options are possible. Now, depending on the text or the assignment, sometimes you'll be asked to give this as a decimal or a percent or a fraction. For my class, for right now, since we're just introducing it, we're just going to leave the probability as a fraction. But on another assignment or on a standardized test, you could be asked to express it as a decimal or a percent. Okay? So let's take a couple examples here. For instance, let's start out again with just that simple die. If I ask you to roll a die, and I could ask you, what's the probability of rolling a 3? So the event that I want is in parentheses, notation-wise, but I could also write it out in a sentence. What is the probability of rolling a 3 on a standard die? Now, most of us for a single die could do this without having to think about it, right? On a die, there are the numbers 1 through 6. So there's only 1 3, 1, and there are a total of 6 sides on the die, 6. So assuming the die is fair, meaning it's not weighted or something like that, that means the probability of rolling a 3 is 1 out of 6. Now, again, a lot of us can do that in our head, but maybe you haven't seen a die before, or maybe it's been a while. You could also use the sample space like we did in 6.1 to also answer this question. So the possibilities are 1 through 6. You would find what you're looking for, in this case 3, which is just one outcome. And there are a total of 6 outcomes in the sample space. Therefore, your answer is 1 out of 6. So either of you will get you there. You don't have to use the sample space, but it might help. Number 2, what is the probability of getting 2 heads on 2 coins? So again, you can use a sample space if you'd like, but you don't have to. I know that if I flip 2 coins, there are 4 combinations. One where I get 2 heads, one where I get a heads, then a tails, one where I get a tails and then a heads, and one where I get 2 tails. So the probability of getting exactly 2 heads is 1 out of, there are 4 possibilities. So my answer would be 1 out of 4, like so. I could increase that to, let's say, the probability of getting at least 1 head on 3 coins. Okay? So now that I'm flipping 3 coins, and again, we could do the sample space if we need to, but that has a total of 8 possible outcomes. So I have heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So because there are 2 outcomes, I'm multiplying the total number of events by each time. So each coin is 2 flips, so 2 times 2 times 2, I should have 8 total outcomes. Now here the probability is asking for at least 1 head. You don't have to write out the sample space, but because I did, I'm looking for, again, there to be at least 1 head. So here I have 1 heads, 1 heads, 1 heads. Now the probability said at least 1, so I could also have 2. Or I could have 3. So that gives me a probability of 7 out of the total number of outcomes, which is 8. So my probability is 7 out of 8. What is the probability of rolling, say, a sum of 10 on 2 dice? Now here, it might help to have that sample space drawn. You don't have to, but it might help. So 1, 1, 1, 2, 1, 3, 4, 5, 1, 6, etc. as I fill this in. 5, 6, 3, 1, 3, 2, 3, 3, 3, 4, 5, 6, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and last, my 6s on the other. Now, the nice thing about doing the sample space for 2 die is that there are a couple sort of shortcuts we can find. Obviously, here it lists out all of our combinations, which is a total of 36. So I know that at the very least, to start out, I'm going to have a total of 36 possible outcomes. I'm looking for how many of these add up to 10. The nice thing about writing out the table like this is that when we look at the diagonals of this table, they will give us the sums, by which I mean if I look at, let's say, this diagonal here, that gives me a sum of 2. And the next diagonal, those 2 values, give me a sum of 3. And the next diagonal gives me a sum of 4, 5, 6, 7, etc. So when I find a set that has a sum of 10, 6, 4, 5, 5, 4, 6, going along that diagonal gives me all the possible outcomes. So my probability here is 3 out of 36. Now, again, depending on the assignment, you might be asked to leave that. Typically, you want to reduce a fraction. So for my assignment, it'll say, if this was a question, 3 out of 36, or if you reduce that fraction, it's 1 out of 12, depending on what you're looking for. So again, those diagonals are nice in solving problems like this when you're dealing with probability. And let's do one more. Let's say the probability of drawing a heart out of a deck of cards. Now, again, you can use the sample space. Really here, though, the easier way to do it is that there are 13 hearts because there are 13 cards in each suit. We said there are a total of 52 cards in a deck. So that is a correct probability, or because every suit has the same number of cards, hearts is 1 suit out of 4. And if you reduce this fraction, you would also get 1 out of 4. Now in 8.2 here, we're looking at simple probabilities. When we get into 8.3, it's going to be a little more complex, but we'll see that here in just a second. So if you guys have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.